In this presentation we are going to look at functions. Now this is the 2003 paper, question 4a. The function f, where the domain is the real numbers, r, and the codomain is the set of integers, z, is defined by the rule f of x equals the floor function. Let's write that in. That's the floor function of x divided by 3. So I'll just write it out there again just to make it a little bit clearer. So x divided by 3. So the first question is find f of 2 and f of 10. Well, okay, so f of 2, function of 2, is the floor of x, which is 2 actually, the floor of 2 divided by 3, and that is equal to 0. F of 10 is the floor function of 10 divided by 3, which is the floor function of 3 and 1/3, and that's equal to 3. Okay, so the answer to the first two, 0 and 3. Okay, so I'm just going to pause it now and we'll do the second one. Find the range of f. Okay, well, we have the codomain there. It's any integer value. The output of floor functions are always integers. So, but in the context of this, is there anything else? So, well, let's just to answer this question, we'll sort of come up with some examples here. For example, the floor function of minus 10 is, or 10 over 3, that is minus 3.33. The floor function of that is minus 4. Okay. Floor function of 30 divided by 3, the floor function of that will be 10. I'm just doing some examples here, and that's just equal to 10. Essentially, we can't. There's no lower limit and there's no upper limit. So it's sort of, there's no sort of a definite boundary. For example, 0. So it's actually once you do a few of these, you realize that any integer value can be the output of this function. So what we're saying is that to find the range is also any integer value. So actually, just as a remark, the codomain and the range are the same. Okay, that's an important matter. That means they are onto as a remark. It's not actually asked yet, but it means the function is onto. Okay. Okay, the next one is find the set of pre-images of 1. Sorry, actually, just as finished or close off on the remark about part 2. It's essentially, after a while, you just, like, if you're not sure, try out a few values, and if you find that there's something, for example, they can't be negative or anything like that, or they can only be integers, that'll become clear very soon. So just if you're not sure, just try out a few. So the next one is find this set of pre-images of 1. So whatever value of x has an output of 1. Okay, so let's just actually sort of naively try out a few values here. So let's say f of 3, and the floor function of that is 3 divided by 3, which is the floor function of 1, which is 1. Okay, let's try out f of 6, and that is 6 over 3, which is the floor function of 2, and that's equal to 2. But just as a remark, any value between 3 and 6 will give you a floor function of 1. So for example, the floor function or the function of 5.99 will give you a 1 also. So the answer to this one actually is, if you try out a few more values like f of 2, which we've seen earlier on, and you will see that the answer to this one is x between 3 and 6, where it can be equal to 3. So x greater than or equal to 3, but less than 6, strictly less than 6. Actually, I'll make that a bit clearer here. Now, notice the two very different relational operators. We have an equality component here, but not here. Also, you should actually add that we have any real number between 3 and 6. So you actually would also additionally specify that they are real numbers. That's to get full marks for that one. So that is find the set of pre-images of 1. Now, say with reason if whether or not f is invertible. Well, and we know it is onto, but is it 1 to 1? It has to be one. It has to be both to be both onto and 1 to 1 to be invertible. First off, actually, let's clear the screen. Well, we've seen here in just when I was looking at the last question, let's just set up an arrow diagram here for a second. It's not actually asked for. But here we can have, this is the domain. And in the domain we have any real number. But I'll just pick out a few anyway. Just a few examples. For example, the codomain there. So, for example, let's say we have 4, 5, and let's say one more. Let's say I'll go for 3.5 just to emphasize that they are real numbers. And over here we have 1. Okay, so all three of these elements and more other than these three elements all are related to they all have the ancestor 1 in the codomain. So in this case, it is not 1 to 1. So in that case, the function is not invertible. So that's the answer to that one, and that ends the presentation.